Hello all. Welcome to the MongoDB webinar development and administration. I hope you all can hear me. Just let me know, just send me a hi smiley so that I know that I'm audible enough. So my name is Rana C, and I'm going to present today's webinar. I'll just talk about MongoDB, some basic concepts of MongoDB, and we'll try to see some hands-on, try to see some how we can develop a quick web application using MongoDB and Spring, and we'll try to develop some functionality, and we'll see the advantage. Okay, so the webinar is a 1 hour webinar. At the end of it, we can have some question answer session. And once again, just to introduce myself, my name is Rana C. I come with around more than 11 years of total industry experience, and I work as an architect in one of those MNCs. And last few years I've been using big data technologies and NoSQL databases. MongoDB is one of them. I have already implemented some couple of projects with MongoDB. Those are already in production, and there are some other stuffs also going on. So in this webinar, I just want to share some of my experiences, what I have got so far with work experience with you, so that it will be helpful for all of you. Okay, I am getting a lot of responses from a lot of folks, so looks like I am audible, and with that, maybe we can start today. Okay, so the things that we'll cover in the next 1 hour is this. Okay, so we'll try to see a very quick comparison between NoSQL and SQL. We'll try to see what a CAP theorem is. Okay, and we'll try to see what are all the features that MongoDB provides, which is kind of advantageous for the applications to be built. We'll try to see some of the job trends and market trends of MongoDB, who are using MongoDB in production today, some of the big names. Okay, and then we'll have some kind of hands-on. We'll try to develop some kind of a sample web application and see that how we can get it work. So to start with NoSQL versus SQL, probably you all know we have been from this RDBMS world. We have been using this conventional databases, so we know the properties. Okay, so they are relational mainly, right? And they support transactions. I mean, all ACID kind of transactions, right? But as far as the NoSQL counterpart is concerned, they are actually non-relational. The moment we say non-relational, right, what we try to mean is the relationships is represented in a different manner. Okay, there is no hard and fast rule of representing the related data into with foreign key constant. Okay, so and that's the reason we say non-relational. When we say non-relational, that doesn't mean that there are no relations between the entities that we are representing or we are building the data model, but the relationships are represented in a different manner. Okay, mostly they are document based, key value pairs, etc. Okay, so when you see, right, you'll find it out, the representation of the data is a little bit different as far as the counterpart, I mean the SQL counterpart is concerned. So in SQL we have seen we have seen a row column structure mainly, right? And but here that kind of structure is not present. Okay, so they are mostly key value pairs or some kind of a denormalized structure and stuff like that. Dynamic schema, very important point for any NoSQL technologies, and that's one of the most important feature being considered today. All right, so what happens is when we say schema, we all know what is a schema. The moment we are trying to build some application, we know that we have to define our data model, right? And that definition is called a schema. So in our SQL world, in our RDBMS world, we have seen that first we define the schema, first we define the DDLs, and then we start our development, right? But here in this case, in the NoSQL arena, we will see that it's pretty flexible, it's pretty dynamic, okay, very fast you can change. So keeping the agility in mind in today's world, with the keeping the pace of the development cycle in today's world, but we actually cannot have luxury to spend time in running DDL, then going through some DBA processes and all, and then do the corresponding application changes. That will actually reduce, that will actually increase your go to market, right? To if you try to stay in the competition, right? So you have to be very fast, and dynamic schema or easily changeable schema will help you a lot in that fashion. Most of the other advantage of the NoSQL technology is that the moment they came into market, right? So all of them, they are based on distributed architecture, right? So we have seen that if you want to get a performance gain from any of the persistent technologies, right? Scaling up or vertical scaling would be having some limitations, right? So for example, when you say vertical scaling, if you increase the resources of the single system itself, you are actually vertically scaling this particular system, right? But if you do that, at some point of time, you'll have some limitations. You won't be able to increase the resources after some point of time, and also that is very costly. Instead, if you go for scaling out or horizontally scalable system, that will give you much more advantage and much more flexibility in performance, right? And control also within your within you. You can scale out as far as your need is concerned. So most of the technologies, most of the big data and NoSQL technologies, they are based on distributed architecture, and that is one of the core feature, architecturally core feature of all these technologies. We have seen, these technologies, they are easily scalable. The moment we are saying easily scalable, so they should provide me some features, or they should provide me some important properties, so that I can maintain the distributed architecture, right? The moment I'll go for a distributed architecture, the moment I'll go for a horizontally scalable system, I'm actually inviting some more challenges. What are all the challenges? Challenges in terms of maintenance, challenges in terms of latency, challenges in terms of high availability, right? Earlier, I had to maintain only one system or maybe two systems, but here I need to probably maintain 100 node cluster, or some 200 node cluster, right? So if that is the case, then obviously your maintenance will be high. So the technology should provide some framework, some platform, so that the maintenance, the failover, fault tolerance would be easy, right? So they should come up with that feature, and MongoDB obviously is one of them. The one other important point of NoSQL is especially MongoDB. The moment you are going for a distributed architecture, right? The moment you are going for a distributed architecture, you should follow a theorem called CAP theorem. What is a CAP theorem? CAP theorem says it basically comes with three aspects of your non-functional requirement: consistency, availability, and partition tolerance. So consistency is how consistent is your system. How availability obviously talks about how available is your system, and partition tolerance, how tolerant is your system even if you are doing some partitioning of the data. Now, what the CAP theorem says, if you are building a distributed architecture, at the same point of time, it is impossible to meet all these three aspects at the same point of time. So that means at the same point of time, if you want to achieve consistency, availability, and partition tolerance, there is a problem. There is architecture, there will be a limitations. So the theorem says you cannot achieve three at a time. What you can do is, the moment you are going for a distributed architecture, you can achieve at least two of it, okay, at max two. So for example, some technologies, they compromise availability, so they concentrate on more on consistency and partition tolerance. Some technologies, they compromise on partition tolerance, okay? So consistency and availability would be a higher preference in that particular sense. So so what I'm trying to say is CAP theorem talks about how a distributed architecture will be designed, and when a distributed architecture will be designed, what are all the aspects to be kept in mind, stuff like that. So all these NoSQL technologies, they don't support the full ACID transaction which RDBMS used to support, right? Especially MongoDB doesn't support the full ACID transaction. Okay, it doesn't support join across multiple tables. Okay, so to speak, what it does is it supports atomic write transaction. That means in MongoDB terminology, we call a table as a collection and we call a row as a document. So what MongoDB does, or what MongoDB supports, it doesn't support the full ACID transaction like atomicity, consistency, isolation, and durability. What it supports, it supports atomic write transaction across one document. So that means at one point of time, if some thread is modifying some document, no other thread can modify that particular thing. Okay, so that atomicity it gives you, but there is no commit, there is no rollback, so to speak, right? So everything is fire and forget in MongoDB. Okay, so some of the top features, let's discuss some of the top features. And basically MongoDB is a free open source software, probably you all know, but just to reiterate, it's a free open source software, cross-platform document oriented database. In MongoDB, everything is a document. So in case of our RDBMS, we used to hear about row column feature. We have seen a row column structure, but here everything is a document. What do you mean by document here? Document is not a Word document. Okay, don't confuse that. Document is a JSON-like structure. Now, if you ask me what is JSON, JSON is nothing but a JavaScript object notation. So basically, it's a combination of key and value, or key or object pair, or key or array pair maybe, right? Which forms a JavaScript object. That's called a JSON. We'll see that in some moment. We'll see some example with some JSON document. So MongoDB has got JSON document. I mean, all the documents are like JSON formatted structure. And in build, when it gets saved, they gets transformed into binary format of it, and we call it BSON. I mean, binary formatted JSON. So it's an open source database, cross-platform, document oriented, which supports dynamic schema and JSON-like documents. Now, coming to a couple of features what MongoDB provides, we'll quickly discuss about it. So as I said, document oriented, we have already talked about it. So when we say document oriented, right, what exactly we meant? What we meant was, for example, let's say if you think of an application that where you want to store title, author, or let's say some information about books, for example. Okay, so instead of storing those documents, those information into two different tables in case of RDBMS, what we do in case of MongoDB is we come up with one single structure of a JSON format, and we save it into one collection. As I said, collection is the analogical term of table in case of RDBMS. So in case of MongoDB, we call collection, right? So that's how that's what a document oriented database is. Everything is a document here. And next is ad hoc queries. It supports search by field, range queries, regular expression searches. So there are features where you can, I mean, these are pretty common features for a persistent technology, so to speak. You can search by field. There are range queries available. You can regular expressions available. Okay. And also you can also project some of the things that what you want. Okay, instead of a select star, you can confine your query, or your return statement with some fields what you want. MongoDB has got a very good indexing support. It has got all types of index. I mean, there are some special type of index like geospatial index. So for example, if you are creating some application with which involves map functionality, which involves location functionality, which involves let's say calculating distance, right? If this kind of applications you are building, geospatial index is something that you can use it, and it's pretty cool and pretty helpful. Okay, there are index like TTL index, for example, time to leave index. Okay, you can save some documents, and after some point of time, after the expiration time is over, it can be deleted automatically. Okay, so those kind of features are also there in terms of indexing as far as index is concerned. Also, there are some secondary indexes concerned. What MongoDB does is MongoDB saves those things in terms of a binary. So MongoDB use a B tree index. Okay, so that's how MongoDB use indexing. Replication, as I said, the moment you are going for the moment you are going with distributed architecture, you are actually inviting challenges. What kind of challenges you are saying? What kind of challenges? Challenges in terms of, for example, let's say you have earlier you used to persist 1 terabyte of data. Right now you are going for a distributed architecture. So what you are doing, you are partitioning your data into multiple systems. Okay, the moment you are going for multiple instances, basically you are increasing your point of failures. Let's say that 1 terabyte of data you have distributed into 10 parts, 100 GB each. Right now, earlier you had to maintain only one system, but here you had to maintain 10 different systems. Right, so but basically you are increasing your number of failures. To avoid, now to handle that scenario, what these technologies should provide, as I was talking about, high availability. That means at any point of time your data should be available. Okay, so the moment you are distributing this thing to 100 different nodes, 10 different nodes or whatever, you should keep in mind that all the nodes should be up. Right, it should not be it should not go down. So what MongoDB provides this fault failover solution in terms of replication. Okay, so to do that, MongoDB use a framework called replica set. Here in replica set, it uses some kind of a primary secondary architecture. Okay, so at any point of time in a cluster, one or in a replica set, one node will act as a primary node. Okay, the moment if the primary node goes down, automatically any one of the secondary node will become primary. There is no manual intervention required. Okay, so that's the automated failover, that's the automated recovery MongoDB provides. Correct. So there will be some downtimes, say for example some 10 to 30 seconds, which is to elect the new primary among the other secondary, but it is automated. So as far as replication is concerned, MongoDB provides replica set, and it provides a primary secondary architecture. The moment primary goes down, other secondary will become primary automatically. Okay, that's how replication works. Coming to the distribution, how the distribution work. So the moment you are loading the data into your MongoDB cluster, this distribution happens automatically. It is called in MongoDB terminology sharding. Okay, and as it happens automatically, we call it auto sharding. Correct. So what does that sharding means? Sharding means the moment you are loading some data, how the data gets distributed across multiple nodes, how the data gets distributed across the cluster. That's called sharding. To do sharding, what you need a specific key based on which MongoDB will distribute the data. That key may be your update, that key may be your create time, that key may be some ID field, that key may be something else based on your non-functional requirement and based on your actual application requirement. Right? The advantage in this particular case is this distribution again is automated. From the user point of view, from the client point of view, from the application point of view, we are totally unimpacted what happens in the background. So MongoDB provides a component called MongoS, which acts as the router, which handles all the query distribution in the back end. But to the user doesn't have to know that which node the particular data resides, which nodes to go and which nodes not to go. That is handled in the Mongo S, which is nothing but the router. Okay, that's how the load balancing works. MongoDB provides another very cool functionality in terms of file systems. File system, in the sense, they call it a specification called GridFS. GridFS is a special specification which you can use to load binary files, like big files like PDF, your image, video, audio, stuff like that. So all these kind of files, right? I know that in our RDBMS world, we used to use blob objects, or we used to use file system itself, our local file system itself, and save the URL in the database, right? But blob itself is very heavy and it's very slow. And also in case of file system also, it is kind of it is not having distributions. GridFS in MongoDB, it provides a functionality, it provides an aspect of creating the big files into multiple chunks. So what happens is, the moment you are actually uploading or saving some big documents into MongoDB, some binary documents, using GridFS specification, it distributes those things into multiple chunks. And the moment you are trying to read it, it's kind of the transaction and the query is again distributed. So the reading is again across cluster. So your reads might be a lot more faster. Keeping the streaming data in mind. Say for example, you are seeing some live streaming websites, or you are seeing some video websites, right? Now those video data gets saved into multiple chunks in MongoDB. Now what happens is, the moment your service layer, it's trying to pull up the information or the video data directly from the MongoDB file system, the GridFS file system, if it is only one block, it will be much slow. But if it is already into multiple chunks, it is faster. That's the way. Okay. MongoDB has got an aggregation framework support. What does that mean? It supports all the complex queries like group by queries, what we used to have in our RDBMS. So this has been handled in the aggregation framework. You can write very complex queries. You can have a pipeline of operations. When I say pipeline of operations, it means there can be chain of operations successively, for which the output of the first operation will act as an input of the next operation. It's kind of, you can take an analogy with your pipe operator in your Linux operating system. It's basically the output of the first operation, previous operation, will act as the input of the next operation. Like that, you can have a chain of operations. That is called aggregation pipeline. In aggregation framework itself, you will have another very important thing called MapReduce. MapReduce is having the same concept here. Whatever the general concept we know about MapReduce, there will be a set of functions called map functions, and there will be a set of functions called reduce functions. Here also the same thing. But the representation here is in JavaScript, because MongoDB understands JavaScripts. Correct? So it has got map functions and reduce functions. You can run those. We call it server-side JavaScripts. The moment you run those, you can have your map functions run first, and then the temporary result you can pass it on the reduce function, and you can reduce the result. That is the way. The next one is kept collection. What is a kept collection? Kept collection is a special type of collection which is of fixed size. The moment you are having a kept collection, the specialty of it is having a fixed size. Number one. Number two, the moment it is reaching it has reached the maximum size of the collection, whatever specified, MongoDB starts deleting the old records. Okay, to get some space with the new records. That's how it works. So the advantage is it is faster. Number one, space wise also it is pretty much efficiently used. Number two. Number three, you can use this type of collections in case of your, for example, some logging functionality, where you are not bothered of very old documents. where you are kind of bothered with the recent inserted documents only. That's the general use case of logging framework. In many of the cases, MongoDB has been used for reporting purposes. MongoDB has been used for logging framework also in many of the applications. That's another advantage. The other advantage, which is the other very important feature which I want to mention here, is pluggable storage. That's a very new feature they have provided with the latest version, MongoDB 3.0. And that's by far the largest release. What does that mean? So far, before 3.0, MongoDB used to MongoDB used to use DB lock. So the moment you are sending some write operations to MongoDB, they used to lock the whole database, and then at that point of time, other write operations are on queue, okay, waiting on queue. That was a kind of mechanism it used to have earlier before 3.0, right? So obviously, if you are using a database locking mechanism, your write operation is going to be very slow. From 3.0 onwards, they have introduced a new storage system called WAT Tiger. Using that WAT Tiger storage system, the locking mechanism has been changed. Currently, the locking mechanism has been established at the document level. So if you are modifying one document, then no other concurrent threads can touch that particular, can change the that particular document. That's how it works. Okay. Then why do I mention pluggable storage here? Because current version, they supports two type of storage. One is WAT Tiger and second one is mmap v1. mmap v1, if you are using mmap v1, it still uses the old technology. That means the DB lock. Okay, so for example, you do not want document lock if you do not have a write heavy applications, you can still use that. But let's say you are kind of using a very write heavy applications, there will be a lot of writes going inside it, right? Then you can use WAT Tiger. The reason I mentioned pluggable storage, because this using of this storage is just a command. You don't have to do anything else. You don't have to hire any other file system or nothing else. It's just a command with the startup options, and that's it. That's how we call it a pluggable storage. And that's again another advantage of MongoDB. Okay, quickly, if you look at this diagram, this will tell you how the interests of MongoDB is kind of getting increased year by year, day by day. So the blue line, it talks about the MongoDB interests, and the red line talks about the RDBMS interests. We have got this from Google Trends. This is how the percentage of queries and all are going. So if you see, starting from 2009, it's kind of it starts growing. So and now you can see the difference itself. One more statistics data we want to present in front of you is the job and market trend. So just take a look at it. So the left side, you will see what is the current job trends with MongoDB currently. Okay, and at the same time, we have also presented some of the other competitor of MongoDB as far as the NoSQL arena is concerned, like Cassandra, Redis, CouchDB. Okay. And in the right section, we have mentioned that what is the market trend, right? So if you see the adoption of NoSQL technologies across industries, okay, we have tried to give some picture. Okay, so that's another statistics that I want to give you. Okay, I'm not looking at the question window right now. I'll take the questions after the session. Okay. Now, some of the companies also, I just want to give you some examples that who are using MongoDB in today's, in production. So eBay is there. We have MetLife, we have Boss, ADP, Forbes. This is just some names I have given here, but there are many more. I myself have used MongoDB in social platform, in some e-commerce applications also I have used. So there are many more actually. Okay, there are some core area also. For example, some data intensive intensive application if you want to build, you can use MongoDB. Okay, so the best part of MongoDB is you can use it both for online as well as for offline big data, right? So let's say if you want to have some offline big data, you have a big storage and you want to run some offline queries and all, right? Then also you can use MongoDB. At the same time, you can use MongoDB for online applications as well, which are pretty much used in today's world. Okay, say for example, starting from reporting framework, starting from content management framework. So many content management applications which have where we store different kinds of contents, different kinds of binary contents, different kinds of PDFs, images like that, right? People use MongoDB today. Reporting is a very highly usable use case for MongoDB today. E-commerce, in e-commerce, the catalog building applications, right? Catalog building use cases, people use MongoDB today. So in case of, say for example, let's say this location specific application or geographical location specific application, they use MongoDB today. Log is one of the key thing, right? We have seen, right, clickstream management, logging. Okay, people can use MongoDB today. So there are use cases and there are applications. So just want to give you some quick idea. Say for example, some weather channel, they turn to MongoDB to get killer features like this. Okay, pretty to use this quickly. Another advantage is the fast development cycle. As I said, very fast you can come up with your data model and start developing. Okay, and the whole point is it is dynamic. Okay, it doesn't have any DDL layer at all. So that's again another advantage. Auto reinvents e-commerce personalization for more than 2 million visitors per day with MongoDB. So that is another use case. Okay, and you can find those details into MongoDB sites itself, so you don't have to spend time here. So MetLife, they have built the 360-degree view of customers for their customers. Okay, and the time taken, they said, is 3 months only. Okay, so that's another win story. One more thing is about ADP. ADP is the application which handles the payroll taxations, okay, for the users in US. So for the new innovative app, right, which handles more than 1 million of users, okay, they have come up with, right? So for that app, they have used MongoDB. And one more example is our Aadhaar card as well, the Indian government Aadhaar card. So you can understand that what is the scale that it needs to handle. Okay, now what we'll do is we'll quickly design an application and we'll see that how we can integrate Spring and MongoDB. Okay, and we'll see some use cases. So the application use case is pretty simple. So basically what I want to do is I want to design a blogger application. The moment I'm talking about blogger application, right, think of from a scenario that if it is a blog, what is the main entity, what is the main use case? The main entity of a blog, obviously a post, correct? So that post, related to that post, other informations will be there. So what kind of information can be there? The post can have title, description, it can have created by, I mean, which user has created, when he has created, it can have comments associated with it, it can have tags associated with it, right? So these are the details a post can have. Now try to think it from this angle. If you want to design this kind of an application using an RDBMS, using an RDBMS, right, how you will do it? So probably the way you will do it is you will create a, if you think this, if you go to this slide, right, if you look into the diagram which is on the left side of it, right, so the way probably you will do it, you will have one table which is called posts, right, and which will have the fields which are related to posts like ID, posts, description, URL, likes, correct? Then a post can have multiple comments. So probably to achieve that, what you can do is you can have another table called comments, and there will be a one-to-many relationship between a post and a comment, correct, and the comments. That's how probably you will do it. And the second table comments can have their its own details, like the comment ID, obviously the foreign key which is post ID, who commented, who gives that comment. So for example, the user, the actual message itself, when the comments has been added, stuff like that, and if somebody has liked that particular comment, correct. The other thing also can be tag also can have a one-to-many relationship with post. So if you try to design this kind of application using an RDBMS at a very high level, I can think of at least 3 tables, correct, at least 3 tables in it. But similar feature, if I want to deploy, if I want to design using MongoDB, let's look at it. So on the right side, whatever I have given, right, it's nothing but the JSON formatted document of a post. So if you see this, right, you have the basic information like post ID, title, description, who has created this, that means the post by, correct. Now with this information, what I'm doing is, instead of creating a separate collection or separate document for comments, what I'm doing is I'm creating an array of a comments object. So in the if you look at this this JSON structure, right, just look at this JSON structure. So along with the fields, whatever is there, what we have done is, instead of creating a separate documents altogether, we have created a sub document or a nested document called comments. And as it can have multiple multiple comments can be associated with a particular post, what we are doing is we are having an array representation. So if you see this, it can have multiple comments like this. At the same time, the for tags also, instead of creating it in a separate collection altogether, I am having an array of tags. So whenever you do, whenever you are, you tag with for a particular post, you can simply change this array. Whenever you do an addition of a comment, you simply add that particular comment in this particular array itself. That's how I can think of. Now 3 or 4 tables in case of RDBMS can be replaced by only one single collection. That's the idea. Now let's go and try to design this application. Okay, so to do that, I am using Eclipse. Okay, so first what I'll do is the way I have started, correct, it's a Spring based application. Okay, so and it's a Maven project. So I'll just quickly show you the dependencies that I have added. These are pretty simple. So there will be some dependency related to Spring framework, okay, and some servlet thing is there. Which is most important for this particular discussion is the MongoDB Java driver. Okay, so this is a dependency which talks about the MongoDB Java driver, and one more dependency is called Spring Data. Spring Data is the is a component of Spring which handles all the related features of NoSQL technologies. So we are using Spring Data MongoDB, like that Spring Data Cassandra is also there, Spring Data CouchDB is also there. So we are using Spring Data MongoDB. So these two are the important dependencies for this particular use case. Okay, now this is the dependency that we have created in the pom.xml. Now I'll look at the Spring XML. So in the Spring XML, what we have done is we have simply created a view resolver. If you want to create some screen, unfortunately I couldn't create any screens here for this particular demo. So I'll just show you that how we can create some services here. And then I have got some package components scan. These are pretty common for Spring. I'm not going there, and some properties file. That's it. Then what I'm doing is try to do a data model. So to do a data model, the basic thing what I have done is the post class. The post is my main class itself. So if you see, it's pretty simple. Simply create a POJO, simply create a plain old Java object with the field that you need. For example, I need ID, title, description, created by, created date, blog URL. Now if you see for tag, what I have done, I have used a set of string so that my tags are unique. Correct? That's the design that I am doing. And for comments, I am doing a list of comments like that. So this is the design of my post object. Similarly, for the comments object, if you go, it is nothing but a list of comments object. So if you go to the comments object, it has user, message, date created, and likes. Correct? So very simple thing. Two Java classes I have created, one post and one comment. You can think of any other programming language also, maybe Node.js, maybe .NET, maybe anything. Okay, I'm using Java because it is kind of a more popular. That's the reason. Okay, so you have created mainly two objects. Now what I'm doing is I have my controller class, and from my controller class I'm accessing different stuffs. For example, so to start with, let me just give you an example. To start with, let's say I'll do a create post. Okay, so to do that, what I'm doing is I'm getting some information about post, okay, in the request body, and this is just nothing but a REST client. Okay, and then I'm passing that into a method called save post. So if you go to save post, this is my DAO method. Okay, in the data access method, it is pretty simple. How I am doing this, look at it. So I am getting that post object. This is nothing but the Java class. Okay, and then what I'm doing is I'm calling dbmanager.getMongoTemplate. Okay, and then the insert command, dbmanager.getMongoTemplate, it gives me a Mongo template. So if you go here and check the implementation of dbmanager.getMongoTemplate, it gives me a template which has the information like host, port, the connection informations basically. Okay, host, port, and then it has information in terms of the connection pool also. Okay, some of the information about connection pools also I have created here. You can have your user ID password also to be set up. So this is nothing but your connection manager, this particular class. It's a singleton class. So I'm using the DB manager Mongo template. Now this Mongo template is provided by Spring Data. It has got a wrapper class of all the data access methods like insert, update, delete, and stuff like that. Correct? So the command is insert, and if I simply pass post, that's it. Now look at this particular code. For this, I don't have to write any statement like insert into table post, then values, then column names, then values, nothing like that. I simply pass the post object itself, and that's it. Now I'll try to save some objects into the DB. So to do that, what I have done is I have got a properties file called sso.properties, and I have some information about my database. Okay, my database is running in my own in my local system, and my database is running at 27017 port, which is the default port of MongoDB. Okay, so to do that, what I have done is I have downloaded MongoDB from the MongoDB site, which is nothing but mongodb.org. mongodb.org/downloads. If you go, you can download different versions. I mean versions specific to your operating system. Correct? So I have downloaded that version, and then what I have done is I have downloaded the zip file for my Windows 64-bit Windows, and I have extracted that. The moment you have extracted that, these are all the things that you will get. So basically you will get a bin directory. Correct? So you'll go inside that bin directory, right? And then if you check, a lot of binaries are provided along with the distributions. For time limit, I cannot go to other binaries, but the main two binaries which I'll be showing now, I'll just quickly explain. So the main binaries of the which basically runs the database is called mongod.exe. In case of Linux, it's just mongod. Correct? So mongod is the binary which runs the actual database itself. Okay, so and then it also provides a client called Mongo. Okay, this is nothing but a client to connect to the database. Okay, so to run this database itself, what you can do is, if you simply type MongoD, correct? If you simply type MongoD, it will start, but it will look for a data directory which is located at your root folder at /data/db. That means if I'm running MongoD and do not specify anything else, it will try to start in a pointing to a default data directory inside the D folder, okay, /data/db. But if you do not have that, then it will not run. To have a customized path, what you can do is you can do --db path, then d colon, then some custom path option. So if I do this way, if I hit enter, then it will start. The database is started, and at the end it says waiting for the connections on port 27017. This is nothing but the default port of MongoDB. That means my MongoDB is running on my local host at 27017. Okay, now to connect to this particular system, I was already trying to do this. So this is already connected actually. So if you simply type Mongo, that's it. So I have again, navigated to the same location and then type Mongo. You can ignore this particular warning. There's a hotfix thing from there, but you can ignore this. Okay, so I have logged into the MongoDB. The moment you log into your MongoDB, by default, it will connect to a database called test. Okay, to check that what are all the databases are present in this particular instance. If you do show DBs, it will list down what are all the databases are present. Now let me connect to the database called Edureka. So to connect to the database called Edureka, you do use Edureka. Okay, to check out what are all the collections are present in this particular database, you type show collections. So these are all the collections which are present. There are UI also available, and some user and client are also available for MongoDB, like RoboMongo, MongoView, any one of them you can use instead of that client. So let's say these are the collections which are available. Now what we are doing is we are trying to connect to this database Edureka, correct? And what we are doing is we are trying to insert the post. And also what we are doing, we are mentioning in the post collection the we have used an annotation called @document and mention collection equal to post. That it means the moment you are trying to add this document into MongoDB or add this object into MongoDB, by default it will go to the collection called post, and that's it, nothing else. Okay, now this is also provided by Spring, this annotation. Okay, now what I'll do is I'll go to the blog controller. So for this I have a endpoint called create post. This is a post method, okay, and it takes a request body as post. So for to access this, as I said, I couldn't create a UI for today's demo, but I'll just invoke this particular REST endpoint separately. So this is my create post endpoint. Okay, for this application, right, I have created a Jetty container. So I'll first start my Jetty container. So my Jetty container is started. Okay, and then I'll copy this link. So this is my create post link. Okay, and here I need to pass on the actual post. Think it from an angle that you are actually creating this post from a UI. So let's say I'll create something that MongoDB development and administration. So here let's say I add something. So this is an introductory session on MongoDB. Okay, so let's say let it be there. Let's say tag is something called MongoDB, and then let's say some other NoSQL. Okay, and obviously when I'm adding, obviously there will be no comment, so I'll just delete this comment section. This is what I'm adding. Okay, this is nothing but the post object. How I am creating this JSON? I am creating based on the fields which I have in my post, class. So let's say ID is an automatic generated ID. I'll discuss on that. So I am mainly mentioning title, description, created by, created date also automatically generated, blog URLs and tags. This is all I am creating currently. Okay, so if you do that and if you click on post, it says successfully created. Okay, now if you go to this database once again, the collection which is created is post. So if you do this, find, use pretty is the command to show it in a better way. So if you type this command, this means select star from collection post, the equivalent statement of as far as SQL is concerned. Okay, if I do this, so if you do that, you will see the actual document is created. Now see how the things are there. So title, description, created by, we have added. Create date is nothing but some date that we have generated. Blog URL, tag, comments is blank, likes is 0. Now if you see this, right, I don't have to specify anything else. The direct Java class goes and directly gets saved itself. The automated generated ID was underscore ID. Underscore ID is nothing but the primary key of mandated primary key of a MongoDB collection. You cannot have a primary key with any other field. Take this. You cannot have a primary key with any other field. Underscore ID is a mandated primary key. If you do not have underscore ID specified in your document, MongoDB will generate an underscore ID by default. Okay, in this particular case, what I have done, I have created, I have mentioned my ID field as the underscore ID field by specifying this annotation called @ID. So whatever value I set with this particular ID, right, it will go and get saved in the underscore ID field. That's how I am doing it. Okay, so my saving of the document is done. Now let's say some other use case to get the document itself, right? So for that I have got one command called get posts. Get post is nothing but I am getting that all the posts which are get saved into the MongoDB. So this is the way that I am doing. So for that you can create a query. You can create a query interface like this, and then generally in the blog application it should be in the descendant. It's in the descendant order, right? So you can create your sort order like that. Okay, and then you can simply fire a command called find itself, passing the query and which class it will get saved into. Okay, it will return a list of this particular class itself, Okay, so if you do that, let's see what will happen. So let's say if you type, now this is a get command, so you can directly put it here. So if you do that, you will get the actual post itself. So once again, this is, if you simply type it here and try to see the JSON, you see the actual thing has come up. Okay, whatever we have added, it has come up so far. Now what I will do is, in the actual scenario, in the actual real life example, right, you might want to see 10 blogs at a time, 10 posts at a time, for example. So in that case, some pagination thing needs to be implemented. Okay, so to do that, there is one more method I have created, though I have not used it here, using skip and limit. What does that mean? You can pass the pagination value on the skip parameter, and you have some limit also. I mean, how many posts you want to see in one page. If you want to do that, if you see this, right, you can have sort, you can have skip, and you can have limit also. Like that also you can change your cursor parameter. Okay, you can modify your cursor parameter. That also you can do. Okay, I have not done, I mean that method is there, but there is no interface actually created. Okay, some other method is also there. So for example, you might want to search some posts by tag. Okay, in that case what you can do is you can pass on the tag. Okay, and based on that you want to search some posts. So to do that, what I am doing is I am creating some criteria, some where field. Okay, where tags is this is nothing but adding a field or running this where criteria on the tags array, MongoDB NoSQL, say for example. Okay, so on the tags array, based on that it will try to fetch the code, fetch the what do you call the posts. For example, if you want to run this particular interface, let's say I can run this one. So get posts by tag. So if you want to run this, obviously with tag 1 I don't have anything, correct? But if you type NoSQL, you will get the post like that. Okay, the same post has come up. So the one thing is you need to create a screen to render this JSON to show up. Okay, now what I will do is I'll try to add some comment. To do that, I have an endpoint called add comment. Okay, so what I'm doing is I want to add some comment, and for that I need to pass on some data. So let's say the ID itself. So for example, what is the ID of this particular post is this. So I'll pass on this. Okay, and let's say Edureka is commenting. This is a sample comments, for example. Okay, and somebody has liked it, the person itself, for example, liked it. If you do that and add comment and do post, successfully updated. So now if you go and check out in the database, same command, now if you see, the comments has been updated with the date like this. Okay, similarly if you go here and try to get the blog, you will see the data is coming up. Say for example, if I post it here, I go plugin JSON where just to format it, I can see comments are also coming up here like this. Now what I'll do is I'll try to like this post. To do that, I have got a particular field called like post, which takes just the ID itself. Okay, so let's say I will do a like post. It just takes the ID itself. Okay, that's it. Post successfully liked. Now if you go here, you will see it has been liked by 1. If you do one more time, if you go here, like 2. So what I'm doing here is, if you see in the like post, I'm getting the post objects and I'm doing an update. So I'm setting up a query criteria based on that underscore ID field, and I'm creating an update where I'm incrementing the like field by 1. For each and every operation, I'm incrementing the like field by 1, and then I'm using this update first. So these are some of the examples that you can use. Okay, and also in case of add comment also, you can see I'm getting that post, and what I'm doing is for all the comments, I am adding the comments object into the comments array. using a function called add to sets. So there are a lot of functions available like that as far as the CRUD operations are concerned. So like that, I can build very quickly an operation, what do you call it, an application of the which contains a blog. Now think of from this scenario, we call about dynamic schema, we call about fast development cycle, right? Now let's change some of the thing. For example, the moment I publish this particular blog applications, it is in production. Now tomorrow some new requirement is coming up. The new requirement is coming up in such a way that I need to have this in the comment section. I have this likes, right? But I don't have any field who has liked this. Okay, who has liked this? I don't have. For example, in the comment section, if you want to change that data model, how do you do? Okay, now let's take an example that how can you change a data model very in a fast way, and you can start working on it. Okay, the easier thing is you go to this comment object. So I have this comments object, right? So what I will do is I will simply create one field here, like by. Okay, I'll create a field here like by. I will create a getter setter method like this, source getter setter. So for like by, I'm creating a getter setter method. So it's done. Okay, now the moment you do this, obviously there will be a need of application restart. So my Jetty container is running here. I'll stop and restart my Jetty container. Okay, so my Jetty container is up. Okay, now what I do is I try to add one more comment for the same this thing. Let's say somebody called Janaki Raman. I can see him in our session. So let's say Janaki Raman. Okay, this blog is useful. And let's say somebody called, Sunil has liked this post, for example, like this comment, for example. Okay, if I do that and use the comment for the same blog. So what was the blog? What was the blog ID? This, right? So blog ID is this, right? And I'll hit the add comment section. Okay, so my functionality is done. It is available. If I do post, okay, some problem. I need to put a comma here. Okay, successfully updated. Now if you go there and try to see the data, see, like by Sunil. So your data model change dynamically added. Okay, no need to touch your MongoDB at all. Your MongoDB is unimpacted. Now if you see this document, right, so one comment is not having this field like by, but the other comment is having this like by field. That is what the dynamism called. That is what it means by dynamic schema. Correct? Like that, you can have any kinds of different permutation combinations of your schema, but obviously that should be related to your application itself. Okay, so yeah, so that's how I wanted to show as far as the blog application is concerned, as far as the blog design application is concerned, data model and representation and the dynamic schema. How can you change your data model faster? How can you implement useful feature using MongoDB with Spring? Okay, so that's what I wanted to cover as far as my discussion is concerned. So now I think it's a good time to have questions. Just let me know if you have any questions. I can see a lot of questions there though, but please let me know if you have any questions. Now we can have questions. Okay, so Janaki Raman is asking what is the certification that has value in the market? Yes, obviously, sorry, Shantanu is asking that. So yes, obviously certification has value in the market, Shantanu. Obviously, if you are certified, then your CV will be high rated. Yes. So Janaki Raman is asking what is the tool you are using to mock your input? Okay, so I am using a Postman client from my Mozilla browser, Janaki Raman. You can use any post client. So there is Postman for Google Chrome also. This is a poster client, okay, from this thing. Pavan is asking, could you name few vendors of MongoDB? So MongoDB is an open source software, Pavan. I'm not sure whether the company who has created MongoDB is called MongoDB only. Yes, that is right, Pavan. Manas Ranjan is asking between MongoDB and HBase, which is the best suited for big data? It again depends on the particular scenario, Manas. But as far as online applications and stuffs are concerned, MongoDB is far more highly suited. But HBase is suited in case of you are running lot of offline batches and stuff like that. Not only that, for example, if your data volume is kind of more than terabyte and coming to some zettabyte or petabyte level, then obviously Hadoop will be the best suited thing than MongoDB. MongoDB is good for terabyte level of data, terabyte and some hundreds of terabytes. Okay, but if it reaches petabytes and stuff like that, then MapReduce or Hadoop would be a better choice for you. Devender is asking what is the difference between Solar and MongoDB. Solar is a search framework, search engine framework, Devender, but MongoDB is a persistence architecture. Two different ballgame altogether. Okay, Solar is the use case of Solar is totally different. Solar can use MongoDB as its own persistence. Solar can use Oracle or Cassandra as its own persistence, or Solar also has its own other persistence also. So that's the difference. Mohit is asking, in big data Hadoop family, they HBase NoSQL itself. Any idea along with big data Hadoop? Some company using MongoDB instead of HBase. As I said, Mohit, it totally depends on the particular situation itself. Use case itself. Most of the companies who are dealing with online applications and trying to connect with database which is faster and highly productive, and the go to market is faster, they go with MongoDB. Okay. Chandrakant Reddy is asking, relation MongoDB to Hadoop, MongoDB replaces HDFS? No. So MongoDB, it's a persistence architecture only, but Hadoop, it comes with the full framework of all different kinds, where HBase is the persistent architecture, but Hadoop has other frameworks also like MapReduce, Pig, Hype, stuff like that. But MongoDB is only the persistence layer. Okay, it two different things. You cannot say MongoDB can replace HDFS, but in today's world, we have some hybrid architecture. Hybrid architecture in the sense we see MongoDB and Hadoop goes together. So there are communications between MongoDB and Hadoop. So for the offline and volume perspective, say for example, as I said, zettabyte or petabyte level, right? We can maintain some HDFS cluster, but your application, to support your application, probably you can use MongoDB, or to run faster query, or to run aggregation query or online big data kind of query, right? You can use MongoDB. So they have kind of complement to each other. Okay. Janaki Raman is asking, for real-time transaction, what is the performance comparison between MongoDB and RDBMS? It's way ahead of RDBMS, Janaki Raman. So as far as real-time this thing is concerned, is way above than RDBMS. Okay. Rakesh is asking, is Java mandatory to build your career on MongoDB? No, Java is not at all mandatory, Rakesh. I just use Java. You can use Node.js. Node.js gel with MongoDB very well because both are JavaScript. Okay, you can use Python, you can use Perl, Ruby, you can use .NET. So any programming, C++, any popular programming language goes with MongoDB. So it's Java is not mandatory. Kalyani is asking, so here is dynamic. Here in dynamic, we can add columns without touching MongoDB, in my understanding. Yes, that is right, Kalyani. That is what I wanted to demonstrate. How is the market of MongoDB in India? As I said, Chandra, I showed you some job trend and market, right? So most, I mean, you know that how many companies are there in India, and most of the there are a lot of startups company who starts using MongoDB. They have started using MongoDB itself, and actually it's pretty good. You can go and have a statistics checks also. Is MongoDB used in HDFS ecosystem? Pavan is asking. No, HDFS ecosystem is totally different. MongoDB is totally different. They can go in parallel, but it is not like one into other, something of that kind. It's not like that. Their underlying architecture is different. Manas Ranjan is asking, what are the limitation of MongoDB, whether MongoDB is preferred for OLTP. Yes, MongoDB is preferred for OLTP, but Manas, as I said, as it doesn't support ACID transaction, full ACID transaction is not supported. So if you have a stringent requirement of having commit rollback stuff, then obviously MongoDB might not be a choice for you. But in most of the scenario, what we have seen so far is there can be workarounds. There can be data model designs, different data model designs, where you can actually use MongoDB even for these kind of situations as well. So limitation, as I said, it doesn't have ACID transaction, it doesn't have joins across multiple documents, multiple collection. You cannot write queries across two collections. You can write query only one collection. That's the limitation. And that's the reason I know we have to design the data model such a way so that you can support write atomicity. You can support, you don't need any join. You have everything in one collection, something of that sort. Okay, not every time it happens, but that's how you should keep in mind. Shruti is asking, hi, can you show an example of complex pipeline query using MongoDB? That might not be possible in this session, Shruti, but it is already covered in our course. So if you join the course, you can, we have a detailed session of aggregation framework and MapReduce, but for this webinar, it is a little bit difficult for me to cover. So Pavan is asking, can MongoDB an alternative for Hadoop? Pavan, I'm saying again and again, MongoDB and Hadoop are two different systems altogether. They are not they cannot be replaced by one another. They have two different use cases. They can run parallelly, but they cannot replace one another. Okay. Okay, I think I answered almost all of your questions, and I hope you have enjoyed this webinar. And so, as I said, if you register with Edureka, you will have lot of detailed discussions and lot of detailed questions answered and lot of other practicals also. Okay. Okay, and I guess all of you are okay, and I wish you a very good night and hope you have enjoyed this session. Okay, bye bye everybody. Bye.